Lagrange equation. And so I'm going to start with the action. So the action is the integral from, let's say, a to b of the Lagrangian, which is a function of position along a path, the velocity and time, and it's integrated with respect to time. So you can think of it as 2 points, and there's a path here, which is this is going to be that path that we take. This is that t equals a and p equals b. Basically, what we want to do is where the Lagrange is going to be when we have zero action. Zero action is going to be if, let's say, we disturb the path a little bit. We add like a little change in the path that we take. So that would be something like x plus an epsilon times a function eta. That's going to be like our little deviation in our path. And if we take the derivative of x with respect to epsilon at epsilon equals 0, that's the variance of x. And then if we have this little change in our path that we take, then consequently our action will also change as a result because we're taking a different path. And to minimize the action, that's going to be when the variance of the action is 0, which is the variance of the integral from a to b of the Lagrangian. Now what we can do is we can rewrite this. So that's, again, by definition, that's the epsilon of the that's going to be so this is what we're going to have. Now if we take this and then apply the chain rule for the multivariable chain rule, then we're going to have the change of the Lagrangian with respect to x times the change with respect to epsilon plus and we're gonna kind of like ignore the time term because time isn't going to be affected by our little change in epsilon. It's still going to end up at the same spots when t equals a and t equals b. So time isn't affected since we're only changing the path. So that term is just 0. And then if we evaluate it at epsilon equals 0, that's just the variance of x. So we can write this as And then what we can do is we can write this as the variance of the derivative of x with respect to time. And then and then the next step would be we're going to apply the product rule to this, not the product rule, but integration by parts to this term here. And this is the integral from a to b of the Lagrangian here, and then I'm just going to copy this in. This part becomes, if we use integration by parts, then after integrating by parts, if you'll notice here, then this part has the variance of x, but we know that at b and a, if we look back at this curve, that there's going to be no variance because it starts and ends at the same points. This term is 0, and 0, which is the variance of the action equals 0, is this. So we know that there's going to be some variance in x, which means that this term will be equal to 0, because we did alter the path slightly, and so this term is going to be a non-zero, and we have 0 is and this is the relation that we get. This is the Euler Lagrange equation that we have derived from the action.